What's this? It's a piece of oak. It's a piece of oak that will pick up your guitar notes. Why is there wires coming out of it? Oh, look. Oh, secret. Let's go and see the first run, or not the first run, actually, the very first gas bass piezo pickup. Let's go. Yeah, so we're diving into what's called the piezoelectric effect. Indeed. I have a very special build coming up, and I want it to be unusual, and I want to fabricate the whole thing myself instead of like buying in parts. We make my own pickups, stuff like that. And I was very interested in the piezoelectric effect. I do have piezo discs, and here's what I'm talking about. It's one of these little fellas. You see that there? And it's got two wires on it. One is like brass, it's a very thin brass disc, okay? And this white part in the middle is zirconate titanate, which is zirconium and titanium crystallized. And the piezoelectric effect is such that when you put stress on these crystals, like I'm doing right now, pressure waves, any sort of vibration goes through, it will induce a voltage that you can measure using these leads. Isn't that awesome? It's alternating current as well, so it's perfect for a pickup, right? You would think. Well, no, think again, and I'm going to show you why. Okay, let's go and have a look. Okay, what you're looking at is this is a mock-up bass that's actually functional. I mean, it works, the string spacing's crap and everything. But what I use this jig, really, it's a jig for investigating new electronics ideas, LEDs, all that sort of stuff, active circuitry pickups. That's why it's got, it used to be an old P-bass body, as you can see, that I routed out a bit more. And what I did was, I built this little wooden box with a nice little engraving on it. Yes, I just disconnected it. I'll reconnect it though. And what I'll just take this apart so you can see it. What I've done is, I've got a regular P-bass passive harness in this. Sorry about that. And sawdust all over the place. A regular P-bass harness in here. We've got volume and tone control and an output jack. Sorry. And I'll leave the pickup wires here stripped so that I can put preamps in there and all sorts of different things to try out different things. So it's good to have this. This actually cost me to make. You've probably never seen this before. I've used this for years. This cost about 25-30 bucks to make. I just needed a reasonably straight neck, you know, an old Fender bridge I scavenged, and part of a pick guard to hold the controls and stuff. That's all. And I use this for prototyping stuff. So let's see what we've got here. We have this little box that I made, like I showed you, and it contains two of these piezo discs connected in series and nothing else, no other circuitry. Now I'm wondering what it's going to sound like passive, and I kind of know what it's going to sound like because I know the characteristics of the piezo discs. So let's get this connected up. Let's connect this to ground here. All I'm doing is wrapping this round. I don't really want a permanent connection at all right now. We're just prototyping. move that aside. Some painter, I've got some painter's tape. I'm going to just take that down. And I'm going to stick this, there's a tiny bit of double-sided tape in there. I'm going to make this contact the body, because I know that piezos rely on vibrations and compression waves. Okay, so I'm just going to stick that in there. It's low down, that's fine. But remember, this doesn't work by inductance, it works by pressure waves. So it doesn't matter how far away or near to the strings it is, it's picking up vibrations from the body more than anything else, right? So let's plug in the crap bass amp, switch it on, and we get a sound. It's very I can immediately hear. I'm going to screw around with the bass, middle and treble on the amplifier here. I immediately hear I can knock all over the body and get really awful pickup noise from it. Right? You can always imagine what if I pick that up and I'm rustling about on the body and stuff and playing, you're going to get all this extraneous noise. That's no good. If I do isolate it from the body a little bit, just isolate it, that goes away, but so does that. So we need some sort of preamp probably in here to amplify whatever signal it's getting while being isolated from the body. That's difficult, right? Let's have a think about this and get back to it. Yeah, okay folks, hello. Yeah, after much screwing around, I mean, I get a semi-decent signal passive, but I think I will need a preamp, and I'm going to design a very simple preamp to start with, and I'll try and get that connected up. I don't think I have the components in stock. I do need a JFET transistor, and I've only got PNPs and NPNs in stock, I think. I'll have a look and see. I don't think I have junction field effect transistors in stock, which surprises me because I use them a lot. Anyway, so let's get designing a very simple preamp circuit that will boost this. Now, this first iteration of this circuit I don't think will give more bass response. It is lacking slightly in bass response from what here, and this is up like 60 to 70%, and I still get that sort of noise. Not as loud as that though. So let's go and figure out what we need to do and get a little prototype preamp going and see if that solves our problem. So let's have a stab at doing this. Okay, I'm probably going to need a 2N5437 JFET, so I'm going to write that down. Junction field effect transistor. Okay, I want something to split the load bias, bias the transistor, so I'm probably going to need probably about 100k resistor. I need a pull up on that. and that will probably be about 3K, 3.3K I think is the K pull up. What else? Might need like a 1 microfarad electrolytic capacitor for the RC circuit part. So let's just put down 1 microfarad right now, cap, and of course I'll need my discs, which I've already got built into there. I'm going to in the pickup itself, let me switch this off. In the pickup itself, I can take this out. All that's in there right now is the discs. If I do, I'll build this circuit externally and see if I can get that to work, because I do have input and output here, so that's okay. I can do that, and if that works, then I can integrate it into the pickup if it works. So let's get to designing this. Let's see. Yeah. Okay, so we start off. Let's just start off with our disc here. Okay, that's our disc. With that there, and we have that there. Okay, so that represents the wires on it. And we can just go. Let's see, where am I going to put ground on this? Where's it going to go? It will probably go. Actually, take it there. That'll make much more sense after I've drawn this. Okay, so we're taking that. Ignore that. That's our piezo disc, and we're going to use as a load for the transistor. We'll use the 100k ohm resistor. So we'll come down here. That is 100k. Now, parallel with that, we are going to have the JFET, the 2N5437 here. So let's draw my best JFET. Doesn't look much like a JFET, does it? No, not at all. But that's the gate. Okay, so gate. That's a drain. This will be the source. So I have to put an arrow there. Right. Okay. So that's the way the transistor will be hooked up. Of course, this is going to be ground. So we'll put GND there, so we know that's the line. We'll come along here. This goes to ground. I believe, if I'm correct. Yeah, that's right. Yeah, that's. Oh God, get this upside down. Now, what I want to do is I want to extend this along. We're going to put a 3.3k here. Oh, it's out of the way. Okay, that's our pull up. Okay, and that's, I'm going to try and work this off at 3.3 volts, which I can do. I want this to be a low voltage, so I've got plus 3.3 here. Okay. Then coming down, I want the capacitor in there. Filter capacitor in there, and let's figure out the chart now. That's plus and that's minus, I would guess. Yeah. So this is going to be our hot line. So that's plus and that's minus. So plus there on this 1 microfarad capacitor. Let's extend this along, and that's it. I think that's it. Yeah. Yeah, I think, yeah, because then you've got the jack plug coming in, or the output. So that's going through there, it's going through there, and you plug in here. Plug in the jack. Oh, that looks like a jobby. So that's a really, I think, pretty simple. And we're going to try that one out and see what that gets us. Might not get us much. 1, 2, 3, 4, 5 components only. And I want this to be 3.3 volts, and this is ground. So I think I'll go and build that and see how it works. Yeah. Okay, cool. So here we are with a completely awful looking, just twisted together circuit. This is a prototype actually. Screw, you know, using breadboards and anything else, and just trying to go to the length to do it. I just need proof of concept right now. So what I'm going to do is solder all these joints together. Unfortunately, I don't have the transistor I wanted or the capacitor I wanted. I have an MPF 102 junction field effect transistor here, and I was really looking for something else, but that's okay. That's all I have in stock right now, and I'm not going to order until I get some sort of verification. This is a 10 microfarad instead of a 1 microfarad electrolytic, and it may be that I'm not going to get the filtering I want from that, so we'll see. I do have the correct resistors though. I've got resistors coming out the ass, so I'm going to go ahead and double check this, and then we'll get to soldering it. Yes. Oh, that's a mess. That's it. 1, 2, 3. A little bit more in there, I think. Yeah, we're done. Tin the tip. Tin the tip. Alright. Let's go and connect this baby up. I'll trim it out a bit and see if it works. I don't even know if these caps are working anymore. They're so old. But we'll see. Cool. Okay, let's see how the little circuit does. I've just plugged in. As you can tell, the pickup still works. So that's a much purer sound. Let me screw around with middle here and treble. Let's turn everything up. Feedback. Aha. Okay, so I put a feedback suppressor in there. It's very close to the amp anyway. Turn down middle a bit, turn the treble down on both sides. That's a marked improvement. Yeah, I would go with that, and surprisingly low noise as well, for it not being shielded at all. Yeah, this will work. I'll just get a PCB made up. There is a couple of things I'm going to put on it though, because I'm still getting extraneous noise from that. So what I want is more gain out of that. You can actually hear me speak through the amplifier. Hello. 1 2 1 2. See, so it acts like a microphone. So we're going to have to filter that sort of stuff out. You can hear it. It's amazing. So that's definitely unwanted. That's still unwanted. But if I cushion this, so it's only picking up devise mechanically something that's only picking up from the guitar, then I'll be fine. Looking good so far. Yeah, onwards and upwards. Let's keep going forward. Of course, the pull-up isn't connected there, as you can see. I'm going to have to power this. I've designed it for 3.3 volts, so I would need a stereo jack in here to use the 3.3 volts. Unfortunately, I don't have a little 3.3 volt battery on me right now, but that'll be for the next episode. Looking good so far. Yes, indeed. Well, hope you enjoyed that little delve into some R&D there. Yeah, a lot of fun. Just a little bit of electronics knowledge required, but other than that, not a problem. I think we can overcome the hurdles that are there, especially with the powering of the circuit, which is fine. You know, I can use a 9 volt battery and put a regulator in there, whatever, you know. But still, fantastic. If you want to see the outcome of this, stay tuned. We'll see what happens. I don't even know the outcome of it yet, so it could be a disaster, but never mind. Hey, if you don't try, you don't know. So, until next time, guys, stay safe, be good, and I'll catch you next time. Cheers, folks. Bye-bye.